educational video series where we learn about an improvement proposal, upcoming upgrades, and basics of Ethereum blockchain. I'm Pooja Ranjan from the Ethereum Cat Herders, and today we are going to talk about Ethereum execution specs. To provide some background, the Ethereum community is progressing towards the merge of Ethereum POW and the Beacon chain. The client devs have started following a new set of terminology to provide a clear understanding of the architecture. So in short, the Ethereum POW chain will be called as execution layer or EL, and the Beacon chain will be called as consensus layer after the merge. And today we are going to learn about executions layer specifications. The consensus quilt mesh team, they have spent a significant amount of time documenting Ethereum's consensus specification of the Ethereum yellow paper in Python implementation. To provide the current stat of implementing the execution specs, we are joined by Sam Wilson from the quilt team. And we also have Light Client, Ansgar Dietrich, Peter Piper Mariam from the team. Thanks for joining us, Sam.
Happy to be here.
For our new viewers, Sam has been on our show multiple times to discuss different proposals. He has co-authored EIP 2938 account abstraction and EIP 3074 auth and auth call opcodes that is also being considered for the Shanghai upgrade. We have recorded an episode on earlier proposal of 3074 with Sam. Full disclosure, specs may have changed since then, but it's a good watch for people who are interested to learn. Moving on to today's talk, I'm looking forward to what you have got to share with us, but please provide a quick introduction for our new users. Over to you.
Sure. So this is going to be a little bit different than other peep and eeps. There's no eep this time. This is more a meta peep and eep where we're going to talk a little bit about kind of a proposal or change. So who am I? Pooja went into this a little bit. I'm Sam Wilson. I'm a developer for Quilt at Consensus AG or Consensus Mesh. I'm not sure what we go by anymore, one of those two. You can find me on Twitter or my GitHub. We also have 4 other people who have been like instrumental in kind of bringing the execution specs project to where they are, and I'm here to take credit for them. We have Somu, who's worked a lot on ETH hash and some of the EVM opcodes. We have Peter, who's worked on the optimized state DB. We have Matt, who's kind of led the project from behind the scenes, and we have Voith, who's pretty much contributed everything about the Homestead hard fork and many other contributions. So without these 4 people, this project wouldn't be here. So we're here to talk about execution specs, which was born as the ETH 1.0 specs repository. Going to talk a little bit about what they are, which is a description of the Ethereum blockchain and its virtual machine, which can be run as a program. And I'll get into a little bit about what that means later on. I'd like to start by giving a bit of an overview of the project, where it's been, where we're going, what we have implemented so far, and things we'd like to see in the future with the project. Then I'll give a deep-ish dive of apply body and a little bit of the future of the EIP process. All of this is tentative and it's mostly my opinion, so feel free to interrupt and correct me at any point in time. So we started mostly as an offshoot of the Consensus Specs project, which was formerly known as the ETH 2.0 Specs project. For those who don't know, that project is a mix of Markdown text with snippets of Python. That's kind of where we got the inspiration to write a specification for Ethereum 1 that is executable. So it's not just a LaTeX document like the yellow paper. This project is going to hopefully be more accessible to developers. And kind of the third thing that got us started on this project is creating snapshots of Ethereum at each hard fork, and not as a series of patches, which is kind of what EAPs are today. So we want to have a way to look back at Frontier and say, this is exactly what Frontier was at this time. Go to Homestead, do the same thing, the DAO, and every other hard fork. We want to know exactly what Ethereum was at that time. And kind of the goals that we're going for, the things that we want to accomplish in the future, we want our spec to be incredibly easy to read. We want it to be easy to contribute to for new people, so no learning a new language or at least learning a fairly popular language like Python. And we want the spec to be easy to maintain, so we want it to be well documented and simple. We want to be able to execute the entire chain against the specification. So we want to be able to take blocks from mainnet and run them against this Python code that we're writing and have the Python code validate those blocks. And finally, the kind of one of the goals we want to do is generate tests for clients. So if you're familiar with the ETH tests, or if you're not familiar with ETH tests and retest ETH, you define kind of like a pre-state and what you want it to look like after, and then you run those tests against a client to generate specifications for other clients. Right now, that role is filled by Geth, and we want to take over that role with the Ethereum specs or execution specs. So now I'm going to go into a little bit of a summary of what the current state of the Ethereum specs is. So what it does, we're functionally complete for the Frontier hard fork. So as far as I'm aware, all of the features specified in the yellow paper are implemented in our specification. We can pass all of the tests that other clients pass for Frontier, and we can execute mainnet up until block 1.2 million or so, which is where Homestead comes in. We actually have a little sync tool that we develop alongside the specification, and that tool can execute all the way up to Homestead. So this is kind of what it looks like right now. So at least on my left here, we have the validate header function written in normal Python with the addition of typing annotations, which I'll talk a little bit about later. So you'll note that we use normal Python doc strings, relatively normal Python, and it generates this output on the right-hand side. So this output is definitely in an early state. It's not going to look like this when it's done. But you can already see that it has a lot of the features of the consensus specs repository. So we have a blurb here of annotations, which eventually we'll be able to toggle on and off. And you actually have the implementation here, which this format, again, comes from the consensus specs repo. We recreated it here, but using a different set of tools. Yeah, so one of the nice things about this that we have over the consensus specs repository is you actually have navigatable links. So if you want to learn more about the header, you can click on that link and it'll take you right to the header specification. So a little bit about the tools we use. We're a completely normal Python package, which is built with Tux. You don't need to learn anything fancy. There's no giant blob of hidden Python code that converts from Markdown into Python. Wink, wink, nudge, nudge, consensus specs. If you can write any Python package, you can write the specs. You can import the specs and use them in other projects. It's plain and simple Python. Our testing is a bit of a combination. So we use the same test that clients use, which is the Ethereum consensus tests. And we also have PyTest flavor tests for things that are more specific to the specification. So for example, our UINT 256 implementation is tested with PyTest, but we do use a combination of both of them. Now for linting, since we're a specification, we have fairly strict rules about the format of the code, how imports are done, and static typing. So static typing is like Java or Rust, where if you say something is an int, it enforces that it's an int. So we use MyPy to enforce those annotations. The code itself is formatted very strictly with black, isort, and flake 8. Normal Python tools just configured to be pretty harsh. There's also spell checking and a few other nice little things, but otherwise it's pretty normal. Finally, we use Sphinx, which is probably the most common Python documentation tool out there. It takes our Python source code plus annotations and converts them into the format you saw earlier. All right, so I'm going to talk a little bit about where we're going with the spec. Again, this is all my opinion. Feel free to disagree. Yeah, so here's kind of what I'm planning for the specs project itself. So obviously we want to complete the rest of the hard forks. Homestead, the DAO, all the way up until London, Shanghai after the merge. Yeah, so probably the next biggest chunk we have to get started on, and probably now is a good time to get started on it, is writing narrative style documentation. So we have our code complete for Frontier, but we have barely any English or natural language documentation. So that has to happen as well for us to be a real specification. Eventually, post-merge, we'd like to connect to the consensus specs project, and we'll actually have to do that to follow the chain. And finally, we'd like to polish the render documentation and theme and make them fit in a bit more with the rest of the Ethereum branding and make it look like a website from 2021 instead of 1990. For tooling. So this is probably the star feature, the number one thing that I'm looking forward to for the execution specs project is rich patches or semantically aware diffs between hard forks and EIPs. If you write an EIP, it will be able to generate a diff like this. You've probably seen similar stuff on GitHub where it crosses out the old stuff and puts the new stuff in and highlights it. So it's super easy to see what's changed between hard forks without having to read through pages and pages of EIPs. So this is probably the thing I'm most excited about, and I'm really I'm thrilled that this is starting to work. I'm working on this myself, and it's coming together slowly but surely. Another feature that we've seen a lot of desire for is toggleable annotations. So if you've seen the annotated specs project, then you'll know exactly what this is. But if you haven't, it's kind of like a longer form English description of what the specification is describing, kind of explaining the rationale behind it, why it is the way it is, and maybe some notes about implementation. So we want that to be maintained in the same place as the specifications themselves. That'll help keep them up to date. And we want to be able to toggle those on and off so that normal people can read the annotated spec, and then superstar core developers can turn them off and just see the code. And finally, this is a bit of a stretch goal. We want to be able to translate the specification into multiple natural languages. So the code is the code, but the annotations and the descriptions, Sphinx provides support for translating into, say, French or Hindi or whatever other language you'd like to translate into. We want to be able to support that. And finally, probably the biggest section for me to talk about is our future plans about how the specifications are going to be used. I mentioned this earlier. We'd like to be able to fill the tests. So taking a set of inputs and a set of outputs and converting them into the format that other clients understand. Right now, Geth does that, and I'd like to see the execution specs take over that role. I'd like to be able to follow the head of the chain as a consensus canary. So right now, there's Forkmon tool that can take multiple clients and watch and see when things split. I'd like to add the spec to that, really helpful for debugging and other things like that. And finally, I'd like to be able to replace the specification section of EIPs with an actual Git diff or Git patch against the active hard fork. And that's probably the thing I'm second most excited for after the annotated diffs, is improving the EIP process. So now I'm going to do a deep-ish dive. I am not the primary developer on this project. I just kind of manage it and take credit. So I'm going to quickly dive into the apply body function and show you a little bit about how it looks and how it gets transformed into the output. And then we can come back to this. So this is the apply body function in the rendered state. So you can kind of see the function signature here with the type annotations. You can navigate through them all and get to the actual implementations. Now here we have kind of a stub note about what this function does. This is kind of the narrative portion that I was talking about earlier that needs to be expanded upon. But this function takes the block body, so transactions, omers, and applies them to the current head of the chain. So description of all the parameters and stuff, and here's the actual implementation. So this portion, all of this code, or all of this HTML is actually rendered from the actual Python spec. It's just copied pretty much word for word out of here and into the HTML. So a little bit of a run through of how this works. Creates the transactions try and the receipts try, which are outputs from executing a block, as well as a tuple of the logs. We quickly iterate through all of the transactions, and for each transaction, we set the try value with at the index with the value of the transaction. We do some checks to make sure the preconditions are correct, and then we actually build the EVM and execute the body of the transaction. Subtract the gas, and then encode the receipt into the receipts try. So this function really does highlight kind of how simple this code is. It's normal Python, implemented almost entirely with free functions, meaning that they're not attached to classes. I'd say around 90% of the functions in the entire spec are side effect free. Yeah, and then so your inputs get transformed into your outputs, and they don't change anything else. And that makes this really easy to follow. The functions are fairly understandable and well documented, and that's kind of what we're going for here. Yeah, so let's go back over here. Probably running a bit long on time, so I'd like to talk a little bit about the future of the EIP process now. So first, a warning. This is a rough idea of what's possible with the specs. Don't hold me to this. I haven't talked to anybody about it. I'm sure there's going to be a ton of input that we need to have on this. This is just what I'm kind of envisioning. So the first thing I'd like to do is formally separate ERCs and EIPs. So ERCs are kind of recommendations on how Ethereum is going to be used. So ERC20, like token specifications, 721, NFTs. Those are all changes or recommendations inside the protocol. So they affect the EVM, Solidity, whereas core EIPs are changes that need to be done in the clients. Now, these types of changes have should be in different repositories because they have different processes associated with them. They both describe different parts of Ethereum, but completely different parts. And the technical reason for this recommendation is because ERCs don't change any of the execution specs. They're implemented entirely within the execution specs, so it'd be difficult to combine them into a single repository. The second thing I'd like to see happen down the road is to relocate EIPs from the repository they're in now into the actual execution specs repository. So once an EIP becomes final, it would get merged into the execution specs, and non-final EIPs would live as pull requests into the execution specs repository. And my final recommendation about EIPs would be to restructure them slightly. So EIPs would be documentation for a diff, as opposed to writing out what changes you want to make in English. So you'd basically get rid of the specification section of EIPs and replace it with a literal code diff against the execution specs repository. Everything else about EIPs, the abstract, the motivation, the rationale, I think should stay the same. Again, the only difference would be to, instead of describing the change in English, make the change with Python. So here's kind of a really, really hastily thrown together diagram of what I think this should look like. So we're currently at fork N. You'd have a bunch of draft EIPs, which are branched off of the master branch. Here, I'm just going to pick some random numbers. Each one of these would live in their own branch. As they become final, they get merged back into the master branch. And then anything that gets rejected would have to be closed and perhaps merged into a graveyard or a holding area, but they don't actually get merged into the master branch. And then the actual fork itself would take place, and then development will continue after that. So I just want to quickly put out a call for volunteers. There's 3 things that I think are really easy to get started on and where I'd like to get some help. One is the narrative documentation. The code's finished for Frontier. But if you can read code or read the yellow paper, I'd love to get some pull requests in to actually start writing the narrative about just like the English annotations. The next thing is test coverage. We've discovered a couple issues while syncing the chain that didn't have test coverage in Ethereum tests. If you know retest ETH or don't mind learning a little bit about it, talk to me and I can get you set up to write a test case. And finally, tooling. So I'm a Rust developer mostly. I'm fairly new to Python, so all of the tools are hacked together. If you know Python, if you're really experienced with it, message me and we can get the tools to be production ready. And that's it for my presentation. Hopefully we have some time for discussion still. I think I went a little long on time, but yeah.
Thank you so much for presentation, Sam. It was too much to take in, like in all, but interesting to know that there are some new processes coming up. And I was really happy to see about this annotated specs for execution layer. I have read about the consensus layer when we saw for the Altair, Vitalik wrote the annotated specs. I am really thrilled to learn about something similar happening in execution layer. Well, at this point, I'd like to open the stage for other panelists of the call if they have any questions for Sam.
So where would this, all right, so you were saying that when you make an EIP and you merge it, it would then be in the fork, then you would like include the change in Python. But when you merge the EIP, would that be like your diff? So in other words, what I'm asking is, would the Python implementation be on the EIP's repo and then you change it? And then in addition to that, you're supposed to include an EIP and then it goes to the repo. Does that make sense?
Sort of, yeah. So I think so we'd move EIPs into this repo, like as a subdirectory, and then you'd make a PR with your code change, as well as a markdown file in the same PR that has the like motivation, rationale, security considerations. So they'd live side by side in the same repository.
So then you would be moving Ethereum EIPs to a different repo, basically.
That's my current plan. Again, I haven't really talked about it with anybody, so if you don't think that's a good idea, I guess now's a good time to say so.
That's fine. Thank you for clarifying. So it's kind of random. Well, anyone else can feel free to jump in, but I noticed that there were like code snippets that you had, like in the diff, right? And it would be interesting to me, like, have you guys ever considered like having like a playground environment or something to like mess around with it so people can like see the change in behavior?
Oh, that'd be interesting, like a live Python environment, like in a browser or something.
Yeah, I wonder if that's possible or if that's just like pie in the sky. But
no, that's definitely possible. Like you can take all of like there's a Python interpreter that you can run in JavaScript, for example. So like, you know, definitely stretch goal, but you could totally replace the JavaScript VM in Remix, for example, with this, and run this, like run Remix against your modified spec. But that'd be, you know, far, far, far out from today.
yeah, it makes sense.
So I have a question that is on like more on a broader level. It's about the language that you guys have chosen about the implementation. You did mention that you are a Rust developer, and I understand this entire implementation is going on in the Python. So why choose Python for this documentation?
Sure. So Python looks like pseudocode. So I think it was a very natural choice for the consensus specs project. And we inherited that choice from the consensus specs project. So that's kind of the history there.
So the current consensus spec is in the Python language. So
there's two kind of approaches. So consensus specs is a markdown file, and they have a tool that extracts the Python from the markdown, and we go the other direction. So we have a Python file and we extract the documentation from the Python. But otherwise they're very similar.
I guess just kind of a meta question, if I could. I'm guessing that the idea here, I think you maybe even specifically mentioned it, is to make this kind of like the canonical specification of what it means to be an Ethereum client for the Ethereum network. What happens if there's a discrepancy between this and the clients? Or even more, like what would happen if there's a bug in the specification? Right.
So I think there's three separate questions to unpack there. So first, do I intend for this to replace the yellow paper? And personally, I would love for that to happen, but that's not my decision. And I think the yellow paper is another like great way of specifying. It's just not as accessible to developers. So that's a decision that the community is going to have to come to. Now, I think your second question was, now I've completely forgotten your original question. Sorry.
No problem. What happens if there's a discrepancy between the spec, and also what happens if there's a bug in the spec?
Right. So bug in the spec is pretty simple. You have to fix the spec and hopefully write a test for it. In the sense, like the same thing that happens with the yellow paper now. If the yellow paper doesn't match what was intended to be done through an EIP, the yellow paper is fixed. So that would be the same here. And if there's a discrepancy between what clients do and what the specification specifies, that's a much more difficult question, because like obviously the network exists and lives, and let's say all the clients implement it in the same way, but it's different than what the specification says, then it's probably easier to go with what the specification says or what the clients say, unless there's some compelling technical reason not to. We would update the spec, but this really has to be decided on a case-by-case basis, depending on what the bug is or what the discrepancy is.
So the EIP process right now, it doesn't have many reviewers. It has one mainly. Well, I guess like client and Micah in particular. But this would kind of introduce a necessity that reviewers also know how to program and know how to program in Python, and know how to review that. And so I'm wondering if you've given, I mean, and this can be, pushed off to another date when you begin to collect consensus about it. But I'm wondering if you've given any thought to how that would look, or how you would kind of not make the pool of people who could review even smaller.
Right. So that's actually a really great question, and I think it's an important one that we should talk about. So I hope that the Ethereum specification that we've written here, like the execution specs, ends up being easier to understand than the specification section of EIPs today, even for people who don't code. So some of the rules we have for contributing to the execution specs repository, actually I don't have an EIP open right now, so I can't pull it up easily, but some of the rules we have for contributing here is that variable names have to be full words, they can't be shortened. Everything has to be very explicit and written in a way that's easy to understand. So if you've ever reviewed an EIP, you'll know that a lot of the EIP specification section is describing like a framework or a language for discussing how the change will work. So you have to define all of these terms. You have to define like what the previous version was and what the next version is, and all of that has to be done with English and natural language. So I think having a line by line diff where you can see like the previous version added 3, the next version adds 5. I think that's going to make it more understandable even for people who don't know how to program. On the flip side, it will make it so that you do need to understand Python or be able to write Python to propose an EIP. And I think that's going to be like narrow a little bit the number of people who can contribute in that way. But the consensus specs are already written in Python and already require that knowledge. So the bar's already been raised. I don't think execution specs is going to be raising it any further than that.
I'm assuming that there's also things that can be done. You can introduce new types of EIPs that don't require that, or like a proposal for an EIP, that type of thing. So that's interesting. Thank you.
Yeah, I think you can always bug me if you're writing an EIP and you don't know Python and you want some help writing it. I'm available to do that, and I think a lot of people would be willing to help translate into Python. At least I hope so.
And I think the advantage of Python also is something that you mentioned before, is that it's a fairly intuitive structure. I'd imagine even people without much of a Python background, just by looking over the code, could probably figure most, at least not exceptionally complex tasks out, even if it's not their language of choice.
Yep, I think we avoid Python specific features mostly as well. Like I think the only Pythonic thing we do is negative array indexing wraps around. Other than that, I think it's fairly straightforward pseudocode.
So I have one more question.
Yeah, of course.
Somebody else can feel free to jump over me, but so the goal is, like, as I understand it, is to provide an easily accessible way for developers to kind of see the difference, the diff between forks or changes. But how do you assure, so like you kind of have this like centralized, like single source of truth of Python implementation, but then how do you guarantee that the clients are going to follow that, or is that you just don't?
I mean, one advantage over Python is that you can translate it into formal verification if you want to, but that's outside my area of expertise. I think it's going to be the same process that we have now with the yellow paper, where and EIPs, where you have to write your EIP, write test cases for it, translate those test cases into JSON retest ETH kind of tests, and then run those tests against your clients. So the process is going to be very similar. Just like you'll be able to fill the tests with the spec as opposed to with Geth.
So If I understand correct, this the effort that has been put around is mostly about like yellow paper in Python, right? The yellow paper itself is editable, as per my understanding. Like it's like maintained on GitHub, and we recently have seen EIP 3607, the reject transaction from senders. This proposal was updated in the yellow paper. So, what was the need for having this documented altogether?
Sure. So there's kind of two parts to that. So one, you can't execute the yellow paper. You can't use the yellow paper to do anything directly. You have to translate it, and there's always room for error there. And second, I think while a lot of people in the Ethereum space are academic in background, a lot of us come from an engineering or development background, and the yellow paper is rather opaque to people like us. And I think that's my main reason for rewriting it.
Right, and this is mostly about like the POW mechanism that you have mentioned. I mean, trying to add it here. So what do you see as the future of this after the merge? Because the consensus would be done under the consensus layer, would not be a part of execution layer. How do you
Right.
see this thing helpful there?
So we don't actually include any consensus. So we don't really describe proof of work outside of the ETH hash implementation. We don't really foresee many changes at all when we come to the merge, because we just don't deal with that. We assume that the blocks we get have a valid difficulty and a valid proof of work.
Interesting. Thank you. Do we have any question from other panelists on the call today? Please feel free to jump in.
That's a really good point in the chat, Tim. The yellow paper gets updated way after everything is finished, as opposed to before. So actually, let me share my screen again here. So go back. Okay, so this kind of a chart here, I can talk a little bit more about this. So right now, EIPs kind of follow along here, right? They describe a change to Ethereum. One of the things that I really want to get out of this project is this merge here. I want to be able to like see Ethereum after the EIPs have been implemented. And that's what the yellow paper updates are. And then, like Tim said, they happen way after they're actually implemented. So I want to give client developers and people watching and dApp developers kind of like you can look at what Ethereum will be once everything is merged together. And I think that's just going to be super invaluable for the whole ecosystem.
I would totally agree to that. I would like to understand some of the maybe opportunities and challenges because the consensus layer, they have the specs written since the beginning of the chain, but on the execution layer, we started it after a period of time, like 4-5 years down the line. What do you think turned out to be the advantage of starting late, or maybe the challenges that you might have faced during the implementation?
Sure. So I think one of the biggest advantages to starting late is that we already have 3 or 4 solid code bases that we can steal implementations from. We don't need to implement everything from scratch, which is great. Like when we're syncing the chain, we actually swap out little pieces of the spec for faster ones that come from other people's implementations. So we're literally just borrowing stuff that's already been done, and that's been absolutely amazing. I think one of the downsides to this is that like we have to describe what's already happened as opposed to defining what will happen. So for example, the difficulty bomb, which is like an adjustment to how much proof of work you have to do, was added well after the start of Frontier. So technically it is a hard fork to add the difficulty bomb, but no one thinks of it that way. There's no difficulty bomb hard fork that happened like after Frontier. So we can't, introduce a hard fork in between Frontier and Homestead just because no one thinks of it that way. And that's one of the challenges that we have to face is we have to match our kind of description of the past to what people commonly believe the past was.
Interesting. I think EIP 100, that was the first one that introduced the difficulty bomb altogether, but that was a part of upgrade.
Sorry, it was a partial upgrade, or
I think that was a part of some separate upgrade. As you mentioned, it wasn't an upgrade in itself, but it was a part of later upgrade.
yeah.
Yeah, so what happened with the difficulty bomb was it was added about a month after Frontier, but it was added in a way that it could basically be retconned back to the beginning because the code as it's implemented doesn't do anything for the first 100 blocks anyway. So if you add it at 50,000 blocks, you can just retcon and pretend that you did that from the beginning of time. And you could do the same thing with banning transactions from senders with code. That was never a rule in Frontier, but because it never happened, people can retcon it.
Yep, exactly. So there are certain changes that aren't part of hard forks that you can implement retroactively because the rules they add were never violated. Yeah, that's a good term for it, Tim. Shadow EIPs.
So I assume at some point in this process, you'd probably want like some attention by client developers paid to this, right? Once we actually start, once you reach parity with Conte mainnet and future EIP proposals will be specified against it, I assume client developers would have to be familiar with it to be able to use these specifications and to go ahead and implement those changes and everything. What do you think, like just timeline wise, is it already far enough in the process that it would already make sense for client developers to start paying attention now? Or is it something where you would want to go get a little bit closer to Conte mainnet before it makes sense for them to look into these specs?
I think the earlier the better for just like the general idea. I don't know how many core developers would actually be excited about changing the EIP process to use this. So feedback on that would be invaluable now. Feedback on the code itself, I think, can wait probably a month, 2 months until we're closer to actual mainnet.
Okay, yeah, that's helpful for context. Thanks.
In fact, my question that I was about to ask is maybe a kind of follow-up of this. Like, we can probably start with a specific category of proposal from which it started. That's what I consider it for to be. It's about the interface proposal. So if not for the entire EIP process, maybe we can do the experiment with one particular category and then try to implement it to the rest of the one.
Yeah, I think a really interesting way to do this would be when we get up to parity with mainnet, every EIP that gets proposed, we create a copy of that EIP against the execution specs repository. That way, like, EIP authors don't notice a change, and we can see how practical it is to start rewriting and switching over the EIP process.
I was curious what you think, Sam, and like what other people on this call think when people ask them, like, can you give me a good place to look for a technical understanding of Ethereum? I feel like I'm getting this question somewhat frequently over the last few months, and I want to like point them to this PySpec. I feel like after the narrative is written, this is going to be a good thing. But until then, I feel like I'm pointing people to the yellow paper, and I don't know if there are other things, other auxiliary resources that people are like pushing people towards.
I haven't really seen, besides the yellow paper, a comprehensive description of Ethereum in one place. There's like a million blog posts, but I think this is going to be probably one of the better ones when it's done.
Maybe we would add all the relevant resources in this description section of this episode for reference, but we would also like to add it on the Ethereum Cat Herders website, that we do some time for some of the upcoming proposals if they are planning to look, I mean, if people are looking for more resources on that. So I'll be happy to connect offline and get more links and get them at one place.
Great, yeah, that sounds good.
Yeah. Please go for it, Peter.
Yeah, I thought I'd give an example of like why having this PySpec, which is very simple and it's actually very easy to make lots of changes, because there's loads of like things that you have to worry about in a real client that you don't have to worry about in the PySpec, like performance, and like we don't have any ability to roll back blocks. other than the fact that you can start a database transaction, do a execute a block, and then and then roll back the transaction. But like the sorts of complicated behaviors that like Geth has to do, we don't have to do. So it's much simpler. And I remember someone called Gume is working on implementing vertical trees in Geth, and he demonstrated on a peep and eep that he had a version of this working with Geth that could talk to itself in vertical tree mode. And I'm like, this is kind of cool. But you haven't like, actually proved anything, because getting Geth to talk to itself anyway doesn't amount to much, but in terms of demonstrating something. But if we had the execution specs, you would have had a verifier in the execution specs that could talk to that Geth and validate its blocks against the specs. And that would have provided a new way to test and implement that sort of change in things like Geth.
Yeah, it makes it much easier to get multi-client anything happening rather than just a single client, because it's so simple to implement anything in the spec.
This is really very interesting.
Thank you.
Any more questions do we have for Sam? Or any final comments or thoughts from anyone?
Yeah, I think that this is an excellent approach to standardizing processes in this space. Great work.
Awesome, thank you.
Yeah, I'm sure people out there are sending their blessings to Kult Mesh team for implementing this spec in Python, for making their life easier.
I definitely hope that it makes someone's life easier. Yeah.
Well, thank you. Thanks once again, Sam, to join us and talk about the current state of implementation of the Ethereum Yellow Paper. So I'm happy to see that there are a couple of things that you mentioned about that we can expect in future, just like the annotated spec for execution layer, and also the adding to the Folkman tool that has been really helpful during the break time, when we know like how many clients are on the same page. So I hope this work is going to be helpful for future upgrades, though only the near future upgrade that we can see is like the Arrow Glacier. I'm not sure, maybe after the merge also this would be helpful.
Yeah, I don't think it'd be ready until after the merge. So
all right, nevertheless, best wishes for that. So on that note, let me thank all our YouTube viewers for watching this episode. I hope you learned something today, and if you did, please pay it forward. Do like and share this episode, and share the link with the community members so people know more about the new and proposed upcoming changes for the proposed EIP process. We have been working on EIP process for over a year now. There have been some significant changes, and with this new proposal, I'm hoping that we would be getting some more clarity, more governance would be around the proposal. So it would be helpful for not only for dev but also for community to understand that. So thank you everyone for joining us today. The YouTube viewers may find the guest contact and related resources of the topic in the description section. Don't forget to share your feedback with us. We'll be back with another interesting topic. Till then, keep watching, keep sharing your love with Ethereum Cat Herders.